So you can go through that and you can do an experiment yourself, and you can change the value of the frequency for lots and lots of different frequencies, and you can plot a graph. And we've already said that what we expect to happen on that is that it lets the low frequency through, but it conducts the high frequency to ground, or in other words, it blocks the high frequency. Well, wouldn't it be nice if we could get an multi-symbolic graph for us? Well, we can. We can. So how do we do that? Well, the first thing we need to do is find my glasses. You can't see it. Here we are. So, if we go up to place, remember where place is? It's where we put the components in. We're going to go to place, but we're not going to go to component, we're going to go down to connector. See connectors there? And I want to select hierarchical connector. Like this, okay? I want one of those. I want three actually. And I'm going to put that in my drawing area somewhere convenient and click. So that's now called IO1. I could change the name, but I don't mind IO1. And next I'm going to place another connector, which is another hierarchical connector. And this one I'm just going to put down here, and I'm going to call this one ground or something. But that's IO2, that's fine. Happy with that. Now I'm going to place another connector. Hierarchical connector. Now I want to look at the output with this one, so I'm going to put this one up here, I think. I'm going to right click on it and rotate it 90 degrees to keep it neat. And then I'm going to wire down to my output point. The same as the oscilloscope was measuring. Leave the oscilloscope there, it won't matter. It's there, why delete it? And we're going to connect there and to there. 30 seconds for you to get that. Why do we attach those I/O pins? It's just because of the way the simulator works. The simulator needs a label point to be able to do its calculations, and those label points are what's just called hierarchical connectors inside of. Okay, so let's press on now. So you'll notice across the top there, there's a nice little drop down here called Simulate. See that? So I'm going to click on Simulate, and if I scroll down I can see Analyses and Simulation. And I'm going to click on that. Now what I've got is I've got a whole series of options on this left-hand side, which are different types of analyses that you can apply to an electronic circuit. Now the one I think I'm most interested in for this one is an AC sweep. In other words, I want to subject this circuit to every single frequency, up to a limit and from a limit, but I want to subject it to all frequencies so that I can plot a graph for it. So I'm going to click on AC sweep. You'll notice that the right-hand side has now changed. I've got start frequency 1 Hz. Well, that sounds sensible because we tried 1 Hz, didn't we, or 10 Hz, 50 Hz, but it was low. So that seems sensible. Stop frequency 10 gigahertz. Well, I don't think so because, I mean, 2.4 gigahertz is a pretty high type of frequency. I'm going to change that to 1 to 10 megahertz, I think. You can obviously experiment with values. So your start frequency on our graph will be 1 Hz. The stop frequency on our graph will be 10 megahertz. We're nearly there, but we haven't actually told the simulator what the input and output pins are. So we go to output, and if you look at your drawing, you may have done yours in a different order, but my output, the one I'm interested in, is IO3. Can I find IO3? Yes, it's at the bottom of my one. So I click on it, and I add it to the variables I'm going to use in the analysis. I could, if I wanted to, include IO pin 1 so that I could see the input, but I'm not terribly fussed about that at the moment. Okay? Now if I go down here and I click the run button, look what happens. I get a marvellous graph, look. So what am I seeing here? If I look at my graph, what I see is that at low frequency, I've got a high amplitude, sorry, the top one. At a low frequency, I've got a high amplitude, and at higher frequencies, I've got a low amplitude. That's exactly what you just saw when you were changing the values by hand, if you remember, isn't it? Except now, automatically, it's done all of those frequencies for you. That's an AC sweep. Look at the horizontal axis. It's going from 1 Hertz to 10 million Hertz. And that's what the graph looks like if you apply that principle of sweeping to your circuit. Okay? And that's magic. So we've created a filter, and we can analyse that filter. So you've got the phase on there as well. The maths gets a bit heavy as to why the phase behaves the way it does, but we can do the maths if we want. But that's not really the objective in 721. Our objective in 721 is to run simulations and produce PCBs.